Welcome to Robominions.in AI interview preparation app. So the topic of this video is in the array ADT we will be looking into linear search. There will be three topics which will be covered. So basic linear search code. Then we'll be looking into optimized linear search using transposition. Then optimized linear search using move to front. Okay. So let's look into linear search code. So we have hash include stdio.h, then int main, so array dt of length 10, size 10, and all the data is getting initialized. 13, 4, 5, 6, 7, 20, 21, 35, 44, and 67. So index 9, 67. Okay. So then we are trying to search the fifth, search the key 5 in the array. So it goes to the linear search function. So I is equal to 0 is it's initialized. I less than the length of the array. So we are using a underscore ptr pointer which will try to access the length. So that's a pointer to the structure array underscore dt. So you can see the ampersand array underscore dt address is sent. Here the pointer receives that address. So the pointer tries to access the length. So 0 less than 10 true. Then if the array element is equal to key, so is whether 13 is equal to 5 false. Now I has been incremented to 1 less than 10 true. Then is so the index is 1 now. So 4 is equal to 5 false. Now I has incremented to 2. Now the array underscore t of 2 is 5. 5 is equal to 5 is true. It has matched. The key has matched. We have found out the index I as 2. So returns. So the search location of 5 is 2. So that is the output. So the basic linear search code. So the basic linear search working we have seen. So the time complexity of this algorithm is order of an. Then we have optimized linear search using transposition. So transposition is using swap. We move the key element to the front. Let's see how it works. So we have included stdio.h. Then we have using array features.h, which uses in that array features we are adding the function swap. So swap will swap the elements. It's a pass by address. So pass by address mechanism we are using. So let's look into how it works. So first we are creating the array underscore dt structure. So it has a length 10, size 10, and all the values have been initialized. So so we are going to call the linear search thrice and see how the location of the element 5 is going to change. Okay. So printf location of 5. So first let's go to the function linear search. So linear search, yeah. So here I less than I is equal to 0. 0 less than 10 is true. So it searches. So first element, it looks for first searches for first, looks into first element, whether it's 5, no, false. Then 4, no, false. Now now going to second element, 5 is equal to 5, true. So I is not equal to 0. So the I was second. So what we do is swap the element between these two locations. So 5 has been moved. It has been transpositioned to this location. So the index has changed to 1. And you return the I. Before the transposition, the location of 5 was 2. So it has returned, so it is given the location as 2, and then the transposition is happened. Okay. So then we try to access the location of 5 again now. So now let's see. So whether 13 equal to 5, false. Now found the 5 in the first index itself. So 1 less than 10 true. So 1 was the index I. So we have found it in the first location itself. So 1 is not equal to 0 true. Sorry, yeah. So now we are trying to swap again, that is transposition the 5 to the index 0th location, index 0. Okay, yeah. So we can see 5 has been transpositioned and the return of location 1. Before transposition the 5 was here, right? So the location is 1. So now again we will try to search for the location of 5. So 0 less than 10 true, 5 is equal to true. We have found it in the first iteration itself, that is index 0. So 0 not equal to 0 false, return 0. So location of 5, now it's 0. The transposition has happened successfully. So now we try to access it again, so we can find it in the 0th location again. So now we can see location of 5 is 0. Now here it has the for loop has turned false, so it comes out of the for loop. Okay, the time complexity of the transposition was, and this algorithm was order of n. Now let's look into the linear search optimized using move to front. So the data will be moved to the front of the array. Okay, so let's go through the code. So array features.h has been initialized. So it has been it has the function swap, and it also has the array structure here, length, size, and array underscore t. Okay, so now array underscore structure is being initialized. So length is 10, size is 10, data has been added here. Okay, first iteration of location, trying to search for location of 5. So linear search. So 0. Okay, 13 is equal to 5 false. 4 is equal to 5 false. 5 is equal to 5 with index 2. It's now it has turned true. So 2 is not, so we can see that 2 is not equal to 0. It's true. Then we swap the 5 and 13. So you can see we have swapped. The 5 has been moved to front. So that is why we call it as move to front. Okay. Then the I has been returned. The previous location of I was 2. So that has been returned. So now when we try searching again, so it goes 0. So the location, the element has been found in the first or 0th location itself. 5 is true. 0 not equal to 0 false. So return 0th location. So location of 5 is 0 now. So again make the search. Again 0th location. Now again make the search. Yeah. So the for loop has ended. So it comes out of the for loop. Time complexity is again order of n. So that was how the linear search code example works. So if you want to use this app, please like the Robominions.in AI interview preparation app, please visit the website Robominions.in. Please download the latest version here. Click on download, then click on download for Windows. If you have a Windows laptop, then then click on download anyway here. We'll look into the next video. Thank you. See you soon. Bye. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.